now let's do the examples. Let's do the math part. Some of you will like the math part better. Okay. So, an object accelerates north uniformly from rest. Every time you see from rest, you know that your initial velocity is equal to 0 meters per second. Okay? So you definitely know your velocity initial. And the time, okay, this is my t. In this time, the object travels displacement, 20 meters. What is the final velocity? Vf. So I'm going to write out everything I know. This is really important that you do this. Sometimes, you know, I go around and you get confused about the question, but you haven't written down your information. Please, please write down your information of the question. So I know Vi is equal to 0 meters per second. T is equal to 2.70 seconds. D, with an arrow, I should draw my arrows, is equal to 20.0 meters. Vf is what I'm trying to find. If you write out everything you know and what you're looking for, these questions will be much easier. Okay? So now you go to your formula sheet and you think, what formula has these 4 things in it? Nothing more, nothing less. Which formula has these in it? So we go to our formula sheet and we check. And you should find that D is equal to Vf minus Vi, right? Right? Vf minus Vi? Or is it plus? It's plus. Oh, okay. Divided by 2 times by T.
We have to rearrange the formula to get the...
Yep. But I'm going to do one simplification. What do I know about Vi? It's 0. So I'm going to just kind of cross that out because there's no sense rearranging with something that's just 0 anyways. So on this side, I want to isolate for Vf. It's multiplied by T. So I need to divide by T, divide by T. So I have D over T is equal to Vf over 2. I want to isolate for Vf. Right now it's divided by 2, so I multiply by 2, multiply by 2. So now I have the formula that I can work with. Okay? So, plug it in, plug it in. Okay, 2 times 20 meters divided by 2.7 seconds is equal to Vf. So you should get 14.814 meters per second. What else do I need to give about information for this? It's direction. So what direction is this traveling? North. Okay? So, and my sig dates. Yes, I heard some of you say that too. 14.8 meters per second north. Okay? Good? Questions? No? Good? Yeah? Thumbs up? Okay, next one. A golf ball is hit from the tee box. The golf ball has a speed of 14.6 meters per second as it strikes a tree. The golf ball bounces straight back off the tree with a speed of 11.3 meters per second. If the golf ball is in contact with the tree for 84 milliseconds, what is the acceleration of the golf ball. So I know my VI is equal to 14.6 meters per second. That's what it was going first, okay? My VF is equal to 11.3 meters per second. What else, though, am I missing? This is initial, but the golf ball bounced back.
So it would be a negative.
That's right. It changed direction, so it's negative 11.3. So make sure again that you're paying attention to your directions for your velocity and displacement. If the golf ball's in contact with the tree, T is equal to 84 milliseconds, okay? So I'm going to change that into seconds. There is 10 to the 3 milliseconds in every 1 second. So I'm going to cross off the millas to be left with my seconds. So the seconds I have is 8.4 times 10 to the negative 2 seconds. Then I'm trying to find A is equal to question mark. So now you look at your formulas, see if you can find a formula that has VI, VF, T, and A. Nothing more, nothing less. So A is equal to VF minus VI divided by T. So I don't have to rearrange for anything because it's just acceleration is what I'm looking for, and that's how it's written. Again, on your formula sheet, it doesn't say VF minus VI, it just says delta V, right? So you need to remember that that delta V really means VF minus VI, okay? And make sure you put it in your negative, so negative 11.3 minus 14.6 divided by 8.4 times 10 to the negative 2 seconds. So your acceleration is negative 308.3 meters per second squared, because that's my units for acceleration, so make sure it's meters per second squared. But now I'm going to put this into sig digs and put my direction in. So A, and I have two sig digs, so 3.1 times 10 to the 2 meters per second squared. What is my direction? I'm going to translate this negative into my direction. What is the direction? It's kind of a vague direction. In reference to the tree, is it going toward the tree or away from the tree? So if we think about it, the positive direction is when it was going toward the tree. Okay? So toward tree is my positive direction. My negative direction, I can just say, is away from tree. So since I ended up with a negative number, I can say that my direction is away from the tree. Questions? Are these okay so far? Doing okay? Good. One more. Oops, I needed to scroll down. Okay, a vehicle traveling along the highway brakes suddenly to avoid hitting a deer that jumped onto the road. The vehicle decelerates at 3 meters per second to a speed of 60 kilometers an hour. According to the skid marks on the road, the vehicle skidded a distance of 56.3 meters. What is the initial speed of the vehicle? So here I am not given direction, like I'm not given east-west. So I'm going to say that my velocity is just going to go in a positive direction. That's my initial direction, right? Initial direction. Okay? Initial direction. So positive. If I'm slowing down, is the acceleration in the same arrow or the other way? The other way. So my acceleration, I need to think about it as being negative. My velocity is my positive. So when I am writing down what I know, I'm going to say that A is equal to negative 3.00 meters per second squared. Its final speed, VF, is 60 kilometers per hour. I need to convert this into meters per second. What's my shortcut? Divide by 3.6. So that's my shortcut conversion. So I get 16.6, repeating, meters per second is my VF. My D is 56.3 meters. And my VI is my question mark. That's what I'm trying to find. So let's look at our formulas and see what can we find that fits all of these things together. What is it, Dylan? What's my formula that I can use? I want VF, VI, D, and A. Can anyone find it? Want to help them out? What about the one that says VF squared equals VI squared plus 2AD? Okay? So VF squared equals VI squared plus 2AD. Okay? I want to solve for VI, so I think I should rearrange the formula first. Okay, so I want to isolate for VI. Right now, VI is added to 2AD, so I'm going to minus 2AD minus 2AD. So now I have VF squared minus 2AD is equal to VI squared. I want VI by itself, so I'm going to square root VI and square root the other side. Okay, now you can put it all in. So VI is equal to the square root of 16.6 squared minus 2 times by negative 3 meters per second squared times by 56.3 meters. So sometimes you might have to do multiple steps on your calculator. If you don't want to do multiple steps on your calculator, you must use brackets, okay? So let's try it. Let's all make sure that we use our calculators and get the right answer so that you know how to put it in. So what you could do is do this chunk first, then go this chunk minus this chunk, and then square root it. Or you can just put it all in. So if you put it all into your calculator, you come up with the square root bracket, and then I would put another bracket and put 16 squared, close bracket, or 16.6, sorry. And then you put in minus bracket 2 times negative 3 times 56.3, close bracket, and then I need to close my first bracket. So you always need to make sure that you're closing every bracket, else your computer kind of goes crazy. Your calculator kind of goes crazy. Okay? So okay. So, what day did we get?
24.76.
Awesome. Is somebody not getting it? So 16. So make sure you've put in that you can get it on your calculator. If you can't, ask me for some help.
If it says initial speed, there would be directions.
Oh, good point.
And would you put your answer in kilometers per hour, because that's what they do?
No, because conventionally it's in meters per second. If it said kilometers per hour, like to give it as an answer, give it as an answer. But the conventions of it, like if you look at the first page, are units generally for velocity. But good, thank you. Hayden made a point that it actually said to give it in speed. So we just write it as VI is equal to 25 meters per second. Thank you. Okay. The last thing is just to fill in a chart that some of you might like to help find what is the right equation to use. So for this, so you can use this as a chart to figure out, well, which equation for which. So the first one, D is equal to VFT minus half AT squared. So this doesn't have VI in it, so you can just leave that as the dark box. And it has VF, has A, has D, has T. The next one, D is equal to VIT plus half AT squared. It has everything but the black box. Next one, D is equal to VF plus VI over 2, all in brackets multiplied by T. it has everything but the dark box. Next is A equals BF minus BI over T, which is the same as our delta V over delta T. And it has everything except the dark box. And then our last one is BF squared equals BI squared plus 2AD, and it has everything except the dark box. So if you're having a hard time figuring out using your formula sheet, you can just use this, look and see which things do I need, look over and see what formula is matched with it. Okay? All right. So next, your practice questions will come from your textbook. I don't know if you have it written down there. Yeah. So the practice questions are page 53, numbers 1 to 7. Okay? So you guys, volleyball players, you can get at least 1 or 2 done before you're called. And these are